Hello everyone, this is a short video to show you how I build the Gobel Power battery box. Let's firstly have a look at what the box contains. At the top we have the plate where the BMS sits on, and at the bottom we have the compression plate which allows the cells to be compressed. We then have a bag of terminals, bolts, various parts. On here we have a part with bus bars, terminal connectors, handles, and various screws and bolts. We then have the isolator, some cable connectors, some isolator fixings, and the wheels for the bottom of the battery. Inside the main box you will see to the left hand side some EVA foam tape as well as other foam. Underneath that you will find the epoxy sheets that we'll cover later in the video. Very briefly, this is the epoxy sheet that sits on top of the battery at the end. We've got various insulators between the cells and the battery box itself. There's some EVA foam, the insulators between the cells, the bars on top of the battery, the box itself, and these are the tools that are required to build the battery. Apologies for the poor photo, but the tools required in no particular order. Starting from the top left, we've got the terminal crimpers, a magnet, a Phillips screwdriver, a socket extension, a 6mm Allen key, a 10mm socket for the drill, a Phillips adapter for the drill, a drill itself, some wire snips, some wire strippers, a long reach Phillips screwdriver, a socket extension, 10mm socket, and the ratchet. And at the bottom I've got some wool tape or loom tape, and below that a torque wrench. Not a particularly expensive one, but a torque wrench nevertheless. Now to start building the battery. Let's start with the first thing, which is the front plate. You will need the 4 terminal connectors as well as the 16 screws that go with these terminals. At the top right you'll also see 4 M8 bolts. These bolts sit into the terminals at the front, which allows the battery to be mounted to the inverter. You can see how the terminals are mounted on the front faceplate. Just please be careful, as you'll see in the next slide, the importance of the orientation is very important. You can see once these are mounted, there's 4 screws sit in there quite nicely, and on here on the back you will see that they form a vertical orientation. This is to allow a bus bar to connect between the 2 terminals. We can then open the JK BMS and remove the communication PCB from the front. You will find also a bag that says JK on it containing the bus bars and other screws. 4 small screws to mount the PCB from the JK BMS to the front panel. Next is the isolator and the 2 red cables. Please note the orientation of the cables. One is also longer than the other. First, with a 6mm Allen key, remove the 2 screws from the isolator. Take note of the orientation of the cables, the short one at the bottom, the long one at the top. And you can see the right angle that the cables sit into the isolator on. 6 screws for the isolator to sit to the plate. You can see in here how it's actually mounted, and you don't need me to speak over this. It's fairly straightforward. But just be careful to push the isolator through correctly into the front of the faceplate so it seats nice and correctly. You can see here I've just used a small case to raise the front plate up, just to give a bit of space to allow the isolator to mount into the front. You will now find 2 other bus bars in that packet, and this is how they mount. Start with the middle of the bus bar, taking a bolt and the correct nut to mount the bus bar right in the middle. Leave it loose just now before then moving it down across the two red terminals. Note, it can be mounted on the front or the back of the terminals. I just chose the front purely because it's easier to access the bolts to screw them in. Continue to tighten up the bolts fairly securely. These will then be torqued to 7 Newton meters before finally assembling the battery. Now we can take the top plate, which is the BMS mounting bracket, and mount the JK BMS to this bracket. It's also worth noting at this point the numbers on the cable connectors here, as we'll use them in later video. This is the orientation we used for the cables. Please note one is longer than the other, and it's very important that they're mounted this way. Now onto the communication cables and the switch, which are fairly self-explanatory and are mounted here. The switch also is mounted into the front plate just by passing through the cable through the circular hole and pulling this tight. Just note that there is a screw on the other side of the switch which is required to be taken off first. It then slips down the other side of the cable quite neatly and then is screwed tightly in place. Now onto the battery box itself. The large epoxy sheet sits at the bottom of the battery box. Then the sides go on like this, and at this point we actually mounted some of the EVA foam at the back, which you can't see. Then the cells are orientated this way. At the back, the positive is in the middle, and here clearly defines how the batteries should be mounted. It's probably worth freezing the video at this point here so you can see the orientation of all the cells. At the top of the picture, you cannot quite see this, but we have the EVA foam plate right at the top to insulate the cells from the battery itself. They then alternate, as you can see by the square QR code, zigzag all the way down to the front. So at the very bottom, it goes positive, negative from left to right. And this is very important, the orientation is such. In between each cell is also an isolation plate, or insulation plate should I say, that separates the cells from each other. There is no foam between the batteries in this design of the box. It's also worth noting that at the very top of this picture we have the EVA foam, but at the very front or the bottom of this picture we do not have the EVA foam as there's not the room. Some cells are different and you may find that you can fit the EVA foam at the front, but for my build on this battery we decided just to fit the insulation plates at the front. There was enough compression across the cells to lock the cells in place. We then move on to the compression plate or the squash plate that sits at the front of the cells. These are the 6 bolts that mount the compression plate. This is how the compression plate is mounted, and you will see that the compression plate should screw hard to the battery box so there's no gap between the cells and the wall of this compression plate. We then set the epoxy sheets across the top of the cells right in the middle. These don't stick to this is just to form some insulation between the cell and the metal plate that sits on top. We then take the 2 metal bars that sit on top of the cells. These are fairly self-explanatory where they sit. These are the bolts that are required to mount these. Please note, there are shorter bolts than these. Please keep 2 short ones aside as they are used at the bottom of the BMS mounting plate, which we're now showing just now. Please note, these are really awkward to get in. You will need a long Phillips screwdriver and some patience, but screw the bottom ones in first on the BMS mounting plate. You can see in the other picture where it's actually mounted. A magnet is also a good tool. This is a picture of the front of the plate with the BMS mounted just now. The screws on the BMS are still loose that mount the cables to there, so we can move them later. Moving on to the balanced cables, you will see there's 4 looms here and they're individually labelled 1, 2, 3 and 4. We cut the ends off the cables, and please note just the ends of the red cables, not the black temperature sensor, as that will cause problems. We take the first one, labelled number 1, and we take it to the BMS. We plug it into the BMS like this. The cables from the BMS are passed through this hole in the front of the box and are routed like so. It looks a bit of a mess, but do you remember this photo? You will see in this picture, on the top left it says NT1 ground. This is the black wire. The first red wire to the left is B0, which goes to this position here. We then continue to work up using every positive of the cell, B1, B2, B3 and so on up to positives. Please note at B8 there are 2 connectors that go to B8. So 2 going to the correct positive there. Just tread caution with that. Probably worth taking a photo of this layout also. Although not quite necessary, I have trimmed the wires just to make it slightly neater at the start of the first loom. You can do this, but just be careful to get the correct wires when you trim them. Strip the wires back and add the terminals on with the correct crimping tool. And just be careful to check that the wires are exactly where they were before. I also use some loom tape at this point to try and tidy things up as well. Moving on to the second connector, it's exactly the same. It routes through the same hole, and here's a video showing the layout of the terminals going up the battery from B0 all the way up to B8. As you reach the top and come across, you'll see at the top right is where B8 is doubled up, and you'll see in the next video when we actually move on to the next one, loom 3 and 4. As we work up, you'll see as we move across that B8 has 2 terminals on it, 2 positives, 1 from the second loom and 1 from the third loom. Just be careful not to confuse that. Then working across simply, working up the battery through cells 9 through to 16, and the last one should go to 16. Try and be as neat as possible. Although not necessary, it's nice to tidy up with some loom tape also. Now for some reason I didn't take a picture of the bus bar layout, but here's one from the seplos unit which is identical. You can see bottom left is the first bus bar, working up from each positive all the way around to cell 16. Once the bus bars have been laid, you can then relay the terminals on top of this and tighten the nut that goes with these bus bars to 5 Newton meters on each one. Time to mount the communication cables to the front plate. Fairly self-explanatory where they go on the BMS and to the correct plate on the PCB, on the switch also. The open terminal on the right you've just seen connects to the main positive on the battery, and you'll see here I've left the BMS cables fairly loose until we can connect the front plate. This is the bus bar that the BMS sits to at the front. When mounted, it can be tightened up. Moving on, you can see I've now connected the negative side from the BMS cable to the main negative on the battery. It goes without saying, be very careful at this point, as if the negative and the positive terminal were to come in contact with each other, you would certainly know about it. It's then time to mount the main positive. You will see also here there's the red cable that goes into the BMS, which has got an open bullet connector. Leave this open just now as it's the last thing to connect the BMS before going on. I forgot to say you can also mount the covers prior to this that insulate the terminals from each other, which is certainly worth doing. It's now time to check the connections on the front plate of the BMS to 6 Newton meters, top and bottom, and the bus bars each to 5 Newton meters. It's now time to connect the BMS to some power. You can join the two connectors together here, and once joined, you can now switch the BMS on at the front by the on-off switch. You may get an alarm signal. This is due to the password that requires changed, but nevertheless, the green light should appear after a beep. You can then apply the epoxy sheet at the top, screwing with the correct screws just to insulate the terminals from the top of the plate. And then you can fit the top plate, and the front plate can be secured in place with the screws. The handles can also be fitted now, and that keeps everything tight. And there's an earth screw at the top right hand corner that can also be fitted. You can then fit the wheels at the bottom, secured by 4 screws, and once that's done, check everything is tight, and that concludes the build and the way we build the Gobel Power battery box.